Good morning, pre-calc. Well, okay, I guess it might not be morning when you're watching this, but hello, pre-calc. We are going to take some notes on 1.6, graphical transformations of graphs. And we are going to start with the difference between a rigid transformation and a non-rigid transformation. So if you know what either of those words means just in your everyday language, let's translate it into something mathematical. A rigid transformation is a transformation that changes like where the thing is located, but does not change the shape or the size of the graph. The shape and size of the graph are unchanged. If you think rigid is like, I can't think of a good word, solid or unbending, right? Rigid. So that would be it's just moved. This would be like a horizontal or a vertical shift, like left, right, up and down, or a reflection of the graph, meaning we're flipping it, but it doesn't change how wide it is, it doesn't change how tall it is stuck, it is rigid. And then of course non-rigid would mean it does change the size or shape. And this would be our vertical and horizontal stretches and shrinks. So in order to talk more about these, we have to remember some things about our function notation. So let's say f of x is equal to 2x plus 4. Really, that's just a line, right? And just reminders, and we did this last time, but I think it sometimes gets, a little tricky in our brains. If I want to find f of x plus 5, that is different than f of x plus 5. In this case, we are plugging in x plus 5 for the x here. So it would be 2 times x plus 5 plus 4. This guy is saying keep the original function, 2x plus 4 f of x, and then add 5 to it. So there's two very different things here. And if you notice, in this case, we are directly affecting the x values. In this case, we are directly affecting the y values, right? Because f of x stands for y. We could put y in there, but we're smarter than that. We wouldn't put y. All right, so let's talk about some transformations. The first thing we're going to talk about is reflections. So we are using h of x to define a new function. So if f of x is our parent function, then h of x is a transformed version of that. So if h of x is equal to f of negative x, let's think about what this is doing. The negative sign is directly touching the x value, so this is acting on our x values. And if I consider what that means I'm switching all my x values that, let's say, are over here to be over here. This is switching our x values, so it is a reflection over the y-axis. It's moving our positive x's to become negative x's, or our negative x's to become positive x's. If I have h of x is equal to negative f of x, notice that this negative sign is actually acting on the y value, right? Because f of x stands for y. So in this case, if I have a function, let's say this is my function, and I change all these positive y's to be negative y's, I have been reflected over the x-axis. Reflection over the x-axis. All right, Now let's talk a little bit about shifting. So this is like left, right, up, and down. And we're going to start by just grouping some things to kind of see patterns here. So if we notice in this first batch, f of x plus c, so c is some value, some number. So this would be like in our first example when I said f of x plus 5, right? This plus 5 is the c here. It's just a number. But if we notice in both of these cases, the x is directly affected. It is x plus c. So in both of these, it is acting on the x values. And because we're talking about x values, think about the x-axis is our horizontal axis, right? This is our x-axis, horizontal. And so all of these things are going to be horizontal shifts. Well, actually, we'll stay here. Okay, so our x-axis shifts are always going to be a little counterintuitive, or at least that's what I think. So when I'm adding c, I'm actually going to move to the left c units. And when I'm subtracting c, I'm actually going to move to the right c units. In my mind, that's counterintuitive because I think if I'm adding, I'm getting bigger, and on the x-axis, right, bigger values are over here to the right, but it's actually the reverse of what we'd expect. So then let's look at these two. These two right here are linked because the c value, that constant, is being added outside of the function. So it's really being added to the y values. This is acting on our y values. Oops, there's an E in there. And so if we're thinking about the y-axis, this is our vertical axis. These are all going to be, let me just move this over. These are all going to be vertical shifts. Now, vertical things are going to act how we would expect. So when I'm adding c, I am moving up c units. If I am subtracting c, I am moving down c units. Let's talk about stretching. So stretching is making it wider or thinner or taller. And the same general things are going to be true. All right, so in this case, the c is directly touching the x. So again, it's acting on our x values. This is going to be a horizontal change, horizontal. And if we notice down here, the c is multiplying on the y. So this is acting on the y values. There we go, which means it's going to be vertical. And similar to our shifting, horizontal things are going to act opposite of what we expect. So if this c value is greater than 1, it's going to be a horizontal shrink. This is counterintuitive in my mind because when the number is big, it's actually going to horizontally get smaller. And if c is between 0 and 1, so if c is a fraction, it is going to be a horizontal stretch. Over on the vertical sides, if c is greater than 1, this is going to be what we'd expect. It's going to be a vertical stretch. And if c is between 0 and 1, it would be a vertical shrink, getting smaller. The other thing that's a little tricky with this is that technically, sometimes a horizontal, so let me just show you a picture of what I mean by this. If this is our original graph, and I take it And imagine I'm grabbing like right here, and down here, and I am pulling up and down. That would be a vertical stretch. What's going to happen? It's going to be like taller and thinner basically, but we could also consider that to be a horizontal shrink where I'm pushing it in from both left and right. We'll look at some more examples, of course, when we are together in class. Then last but not least for these notes is absolute value transformations. So there's two different absolute value transformations. We can do the absolute value of the function, or we can do f of the absolute value of x. So of course the same general idea is happening here, where it's either acting on x values or y values. In this first case, I'm taking the absolute value of all my y values. So you're making all y values positive. When we do this, any part of the graph that is below the x-axis gets reflected above the x-axis, right? Any negative y values get flipped up to become positive. In this case, we are making all of our x values positive, making all x values positive. And if we are doing that, then any part of the graph that is on the left side of our y-axis is going to be reflected over that y-axis. Again, if you think about it logically, if I have a negative x value on the left side of the y-axis and I'm making that positive, it's going to be reflected over. We will do a couple examples when we are all together in class, but I hope you have a lovely day or evening whenever you're watching this.